welcome to day two. Today we're gonna, as David said, we're gonna cover some basics about some changes that we plan to make to the Lotus runtime architecture. I think I was told that Juan presented. I wasn't here for day one, but I was told that Juan kind of like presented a little bit of what we're calling the architecture for the golden path. And you see that there are two. Let me change one thing on my screen because I think it's a little bit yellow. I don't know if you saw that tin.
We don't see the flux.
All right, you don't see that. All right, okay, cool. That's great. Yeah, because I had flux and night shift enabled both at the same time, so they were compounding and it was really yellow. Anyway, yeah, so we're gonna focus on two elements of this overall architecture diagram. Has this been covered in this session?
We briefly showed this diagram earlier. I think what maybe it is useful to have a little bit of context, which is, so this sort of is thinking about, okay, we've got existing Lotus clients and miners, and there's work to do, especially on retrieval side, to make it more easy to get that content, right? And that is what eventually that's this path towards a retrieval market. And so in the shorter term, what are the next steps that we should be thinking about evolving more concretely to get towards this market that we're headed towards? And so I think what the next piece is sort of more core, like next steps that we can imagine on these two highlighted portions of this. So how is a Filecoin miner going to change, and what needs to happen there to make itself more easy for external clients to get stuff out of it, and then introducing the start of some interfaces and then implementations of this network indexer thing that's here, which is we need some way to quickly learn which miners have which content, and so how do we start evolving that subsystem?
Exactly, and we can potentially dive into other areas of this diagram as well, but the areas that we're focusing on today are the ones that we believe are highly relevant to the retrieval work here, because there are things that are going to be that we plan to change on the architecture that are going to of Lotus itself, and those principles we propose that other clients also adopt them. And of course, this is an open conversation, so if you think that there is we're going in the wrong direction, or there are things that we haven't considered, then this is a really good moment to actually voice that out. There are going to be more discussions in the community around these changes that I'm gonna be presenting today. We are within kind of like the Lotus maintainers team doing a little bit of the initial work of getting the rough ideas, getting an internal consensus before we actually start engaging the actual stakeholders of all this in the community, and open up the conversations a lot more. So these two elements I think are highly relevant to the retrieval markets work. So let's dive in. All right, so what I'm going to be talking about personally is the evolution of a Lotus node, and really the kind of like the thread that is open right now for us relates a lot more to the architecture of the miner itself. So we're not really looking at the holistic picture of a Lotus node as it is, but I think it's a really good opportunity to do that now, as retrieval markets is really the initiatives that you guys are going to be working on really potentially need to evolve the larger scope of what a Lotus client is, not just the miner part of it, but kind of like the whole architecture of the client. So just to give you a little bit of context, Project Bedrock, Retrieval Markets, and other projects are intending to introduce new capabilities to the Filecoin network. So we're talking about indexing, CDNs, payment channel networks, not payment channels, those already exist, public retrieval, and many of these initiatives actually require new capabilities and new logic on the miner side of things. On the other hand, we have miners that have actually worked around features that they personally consider unstable or unprofitable to run for now. And this is basically a good signal that they want more flexibility, right? Because the moment that you take the stock product and you modify it to remove things, or you short circuit certain features because you don't want to make storage deals, or you don't want to serve retrieval deals, then these are these are really good indicators that the product itself should be giving miners, like there should be some more embedded modularity within the product itself, within the code itself. So we also detected that the monolithic Lotus architecture is quite limiting in terms of like many things that I'm gonna be touching on. So just to give you kind of like the initial picture of what the status quo is of Lotus itself. First of all, Lotus, we consider it largely monolithic, but it does have like some small sprouts of like a little bit of physical segregation of responsibilities. Concretely, you will be familiar with there are two entry points into the Lotus binary itself right now as it stands today. We've got the daemon and we've got the miner, and these two have some, these two perform entirely different responsibilities. So the daemon is owning chain sync, it is offering the full JSON RPC, it's offering wallet functionality, and it's offering a bunch of other things. And the miner, on the other hand, is taking care of sealing, running storage deals, retrieval deals, and a few more things. Now, there are also a few commands that also encapsulate specialized small services. Like, for example, there are commands or Lotus shed tools that run the off-chain window post challenger or the consensus form reporter. So there's already kind of like an emergence of like encapsulation of potentially services around the Filecoin network or responsibilities that could be considered self-packaged services that are being provided to the Filecoin network. However, if you zoom into the miner itself, you see that the miner is taking care of sealing, storage deals, and retrieval deals, and a bunch of things more that I'm going to outline in the next slide. And this lack of segregation between like all the things that the miner, that single binary process is taking care of is problematic for several reasons. And we also got to like take into account that most miners seek to sort of like maximize their economic profit. And they seek to undertake as little operational risk as possible. So just to kind of like outline what the responsibilities of Lotus miner, the binary itself are, and this is like a non-comprehensive list. We've got participating in storage mining, onboarding storage, coordinating the seeding activity in the pipeline, sector proving, block mining, and then we've got evaluating and accepting storage deals, conducting the data transfer, assigning deals to sectors, blah, 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 taking care of serving those deals, and a bunch of other things. So really, there are like two big chunks of functionality that the Lotus miner binary is taking care of right now, and those are mining and markets. And this is the initial segregation that we're proposing to do. And you'll realize that these two layers have very different quality of service and SLA requirements, right? The mining operation of a miner is really right now the most profitable activity of the miner, and it actually can be entirely private. So Lotus miner is an entirely private thing that interacts with the daemon to interact with the network, right? But the mining activity within Lotus miner could stay entirely private. However, markets is by definition entirely public facing, right? So now you've got these two like disjoint, critical, like two pieces that have different criticality that also have different levels of exposure. Right now, two should be having different levels of exposure to the network, but are being bundled into one thing that makes it like more fragile than it should be. So precisely, what are the problems with this architecture? On the one hand, I just talked about that fragility. Bugs in one area of the code can impact other areas, and this means that non-critical processes, or what miners can consider today to be non-critical processes, can end up affecting the operation of critical processing and potentially even crashing the instance, right? This lack of isolation also leads to an increased attack surface, because we've got processes that require public endpoints, and now attackers can use those public endpoints to attack the critical processes that actually don't require public endpoints, right? Or are fronted by another process that is doing the public interfacing with the network, right? Like the Lotus daemon. And also, like, it might not just be attacks, it might be legitimate traffic spikes, right? So we've got different workloads here that have different levels of predictability. And when you're serving deals and potentially retrieval deals, you can't really plan for the amount of traffic that you're gonna receive, right? So any activity on that endpoint could potentially deschedule or displace or impact other critical processes. Now, as we add more functionality on the miner side of things, like for example, indexing, and Will is going to talk a little bit more about that. We really don't want to like continue bloating this one thing that miners are running, because it's going to make them even more apprehensive to like adopting those features, right? Other problems are it's hard in the current arrangement to scale specific features independently of others, no matter they have different quality of service characteristics or SLA requirements or criticality. As I said before, some activities are like, potentially scheduled, like the sealing activity can be predicted ahead of time, but other activities might be unpredictable, bursty, and this like is very incongruent, one thing with the other, and we need to fix that. Other problems are the lack of deployment flexibility. So for example, with the current architecture, it's impossible to segregate responsibilities in different subnets. So miners might want to have different responsibilities running in different subnets that are completely isolated with one another. It is also difficult to introduce highly available setups with failover, clustering, or it's difficult to, for example, orchestrate. If you want to have a farm of retrieval workers, for example, serving that dynamically scales with the load that comes in from the network, right, via using something like Kubernetes controllers or whatever, that's really hard to achieve because it's all bundled into a single process. And also, like as I said, load balancing, firewalling as well. If you want to protect these public-facing endpoints to like prevent denial of service attacks or other things, it's hard to just achieve that level of like protection for this particular type of workload, right? Another thing is that miners cannot cleanly opt in and opt out of features, right? So right now, what miners do is they work around them, potentially sometimes like finding ways to short circuit some features, like for example, refusing deals or pricing them with like outrageous amounts so that no deals would be made, right, with them, or outright rejecting them. Or they can even resort to forking the code base. And all of this kind of like leads to innovation slowdown as well, because ideally, as we introduce more and more features to the Filecoin network, we would like to tag certain features as experimental features and have miners or other clients run those features in a separate subnet that is like governed in a different manner, that is completely isolated from everything else, right? Because they are experimental, so you don't want to affect your production setup, right? So what we've been thinking of is kind of like already paved the way and like set the stage for this. We are right now thinking about separating the Lotus miner process into the Lotus markets process and the Lotus mining process. The Lotus mining process can stay entirely internal. The Lotus markets process can be fronted by, it would be the external facing endpoint of a miner, and it's gonna like run all those processes that have to do with storage, providing storage, providing retrieval capability, indexing, and so on. And it's going to speak with the Lotus mining process and the daemon process. And this is like a very initial sketch of a potential direction in which we can go. One key thing that we would like to do is like keep the runtime and the operational side of running these processes really simple, and I'm gonna talk about that a little bit later in the next slides. Right. So one idea that I wanted to introduce is, that you've seen that kind of like my whole talk has revolved around what we want to do in the Lotus miner itself, right? But there is opportunity to, as we dive into projects and concretely retrieval markets, which is like going to be composed of a lot of services that provide functionality and like together make up, the ideal retrieval experience for users. Do we want to consider Filecoin potentially as a layer 1 protocol that offers foundational primitives on top of which a plethora of services and capabilities can be built? So do we want to like move towards a capability, like a capability oriented deployment, right? So like users and clients would be able to start Lotus and just run the chain capability. If all they want to do is follow the chain and interact with the chain, maybe potentially start just a Lotus wallet capability, or start a retrieval capability if you're a miner, right? Or like, how do we want to kind of like make the ability to select what features we want to run from kind of like the Filecoin network easy from the user's perspective, right? But we got to be careful because capabilities can be stacked or interdependent. So for example, storage deal making depends on the chain. Indexing operates on storage deals, right? Like if you don't have a storage deal, then you have nothing to index really. Retrieval can only happen if there are storage deals. So like all these things are like, if you break apart all these services, then the reality is that these services will end up having dependencies. So some services would be downstream consequences of offering another service, right? So these are things to take into account. I just wanted to like put out there some of the design principles. I've been out of the office for 1 week, but the team has made a lot of progress, and I've kind of like picked up on what the team is considering the current design principles of how we want to conduct this potential re-architecture of Lotus. First of all, we are explicitly staying away from microservice architectures or microservice-like architectures. And when I talk about this, I mean, service meshes and things that are super complex to operate in practice, because they end up be like enabling or permitting patterns of like spaghetti interactions between a lot of pieces, creating webs of interdependencies that are really, really hard to debug. And like, we think that that is the wrong level of complexity to introduce in Lotus. So definitely staying away from those patterns. We want to make sure that we maximize the operational simplicity for users and miners. And we are adopting or moving towards a hub and spoke architecture. So the current design, and this is very much in draft because it needs to kind of like be discussed with the community and also internally, because this is like fresh out of the oven internally within the Lotus maintenance team. We think that one potential right approach here could be to have supervisor instances which know which capabilities are provisioned in the deployment. So if you have a miner that is offering, that is obviously doing sealing and is running a farm of retrieval nodes, a farm of storage nodes, and is running as well indexing nodes and a bunch of other things that might come down the pike, the supervisor instances would know which capabilities are provisioned by which nodes in the network, right? So there would be a way for nodes to be discoverable or to be explicitly registered with those supervisors. And once you have this kind of like level of oversight, of insight into the network, the supervisors themselves can serve as the external JSON RPC API entry points. So rather than, now that you've like divided your functionality into many components that are placed in different machines, now do you want to, like, we don't want the user to have to face, or the end client to have to face the ultimate like complexity of dealing with where is each thing. So if I want to invoke a particular JSON RPC method, we don't want the client to have to like figure out which is the instance where they need to invoke that method. So supervisors knowing which capabilities are provisioned by which nodes could also serve as the JSON RPC API endpoints. And at this stage, we're thinking that routing could be done in a reverse proxy manner. So basically the request comes into a supervisor load balances, and then just does a reverse proxy. One really key thing here is, I mentioned it before, there are dependencies between these services. So supervising the process lifecycle of everything that is running in the deployment is really critical, because if something fails, and that means that downstream other services are going to fail, then the entire system must be able to notice and react, right? So one potential idea here to simplify the operational side of things is, instead of having like each of these potential processes be a separate physical process, we just have Lotus be Lotus with a start command to which a operator can provide a services stack. So you provide a flag and you say, I want to run markets and miner. I want to run this and that. And this allows operators to build the kind of deployment. It gives them that deployment flexibility to be able to place the exact workloads they want wherever they want. And there are many sources of inspiration for kind of like the modularity discussion and kind of like the supervision and the management and like the lifecycle management and the dependencies and so on. And I've just cited a few. And we think, or like this is more an opinion, a personal opinion. I think that this is definitely worth the investment because I think that the return here is going to be on higher reliability, security, and development agility, robustness, not just for miners and operators and node operators, but also for, you know, as a result, collectively for the entire network. Here are some resources. So there is everything. Most of what I've covered today is covered here in the miner runtime segregation proposal. I know I'm a little bit over time, so I'll just wrap up quickly. So make sure to read that if you're interested. And then there is also a draft prototype of the separation in Lotus of markets and the miner, kind of like as a starting point and as an initial stab to this.
And we'll get these slides shared as well. So
yep.
They'll end up in the channel as soon as I guess we get through talking over them. I don't know if you want to keep doing the slides or switch to have me screen share for this next thing. Yes, I will do it. Same deck. All right. Okay, so